The next topic is OmicsCircos for genomic visualization. So what is that? So it's a visualization tool, so used in genomic research to analyze genomic data in circular format, like shown here on the right. I used to see it all the time in TCGA papers. It's used a lot in genomics, but it can be used for other types of data as well. So it's based on a bioconductor. It is a bioconductor package. So it shows the whole genome at once. So usually the main sections are chromosomes going around the circle. And then I think one of the key things is you have these lines, these links in between parts of one chromosome to another chromosome, so you can see fusion events. You can really pick those out easily. Of course, you want to filter down for, you want to massage the data to see like the most significant events. So you could have fusions in the middle. You could have heat maps for mRNA expression. You can have GWAS data where you have sort of multiple circles of Manhattan plots, because Manhattan plot is by chromosome, right? So you could do that as well. Cytometry, does it relate to cytometry data? I'm not sure, but that would be cool to try. But of course, it's all about multi-omics. So genomics, transcriptomics, proteomics, etc. This was developed by Dr. Meersman's lab at NCI. So some use cases. So this is not actually OmicsCircos. It's from a different R package, but I thought it was cool that if you do know some R code, you can make some really interesting things, like a dartboard or some of these other things. So they get pretty complex. So it's kind of like you have to hold yourself back and not put too much data, because there's only so much data like the human eye can read at a time. But I think it's, especially for structural variants, I think it's, copy number variation, fusion events, super important there. So how did we implement it? So the implementation is unique here. So it's implemented as an interactive web application. So there's bioconductor. So what we could have done is, create CWL or WDL apps, right, to run this bioconductor package. But in this case, we made a R-Shiny application, and so that's hosted on Biodata Catalyst. So it would enable pure biologists to create these plots. And so this was also a collaboration with the Meersman lab at NCI. Oops. So I wanted to demo this for you. So let me show you how to get, so I'm not even logged in. So let me log in on another screen.
If there are any other questions, just a reminder to, you can put them in the chat, use the raise your hand feature, or if anybody has a quick one now, we could probably address it while Dave's logging in. So don't be shy with questions.
So this is my dashboard. So remember, everything I talked about today is under the public resources drop down. So you have workflows and tools, which are the CWL apps, and then you have something new called interactive web apps. So if you click on that, there's 3 currently, but we want to keep adding more. So there's a couple for, well, there's one for Genesis, there's Locus Zoom, and the new one is the OmicsCircos app. So what you do is you click open, and it'll open up in a new window, which I'm going to put over here for you. It looks like this. So here, oops, let me make this better. So it really opens up in a new web page or a new tab, but it's still behind the NHLBI BDC firewall, so you have to be logged in to see it. It's not public, but it has. So this is the difference. So this is an interactive way to do your analysis, and it works very well for sort of things at the end of your analysis, like particularly visualization, because the data is already sort of reduced in size, and you kind of want to fine tune things. So of course you have a user guide here and references. So if you click Start Discovery, it could be my voice. I don't know. How am I coming through, guys? Is it okay?
It's okay on my end.
Okay. Yeah, that could be my microphone. Um, so this is how you would walk through the pipeline. So the Shiny app. So what's interesting here is that you have this toggle button here. So it has built-in data that you can use to play with, which I think is a great feature. Of course, you can use your own the data from the platform as well. So Genesis tutorial. It's probably going to complain because I'm not logged in. So great question, Prithvi. So he asked what kind of data should be given. I've never actually used it with GWAS data, but I like to try. This example is going to walk you through there. Let me refresh this. I think I'm logged out. This example in particular is going to walk you through mRNA fusions, basically omics data. So if you want to use the built-in package data, just toggle that. And so what example data? So it's select example data sets from the omics package. So what you want to focus on is up at the top, what sort of tab you're at. So segmentation, mapping, links, and then link polygon data. So segmentation would be, how do I describe this? So I think the chromosomes essentially. So it has HD18, HD19. So you just have to be careful. You can use you can use anything. I suppose there's you could use version 38 as well if you had that file in your project. So these are just the example data sets. So you click load, and then so what do you want to map? Once again, I'm using the built-in data as well. So for mapping data, we can use like the gene expression. So load those up. I think I'm doing this right. I'm a little out of practice, guys. So the link data would be fusions for sure. Link polygon data. So by the way, these are all TCGA, Cancer Genome Atlas open data sets. All right, let's see if I did this right. So, oops, let me zoom out. Okay, so we have our input data. At least we hope we do. And then we go to visualizations. So you can sort of interactively add all these segments. So you can have chromosomes, heat maps, links, different types of links. I think that's right. Okay, so you have each of these features, right? So you add them one by one, and then you click generate plot, or you could generate. Let's see if it gives me an error. Didn't give me an error. Okay, and you build a plot over to the right. What is the settings? Oh, you can change the title. It's very interactive, and I haven't used it enough to get really good results. But let's try to add a heat map, I suppose. Heat map would be gene expression. And what's interesting to me is, I guess we would add it by sample, I suppose. I don't know. And then regenerate the plot. Okay, and so that didn't turn out too well, but you can always change the circle radius to get it better. So you see how the interactivity comes into play here. It didn't work. Oh, generate. Yeah, so you would move the different circles around. Let's try to get some link data. Colors, use that. I did set the colors. Okay, well, it won't be win any awards, but I think you get the idea. So if you want to use your own data, you would go back to the input data and untoggle the use package built-in data set, and basically pick your project, pick your folder, and then select the file. So great question, Prithvi. So I think we should follow up. Can we actually get this working with GWAS data? I think that would be fantastic. So any questions about that? About
what does it mean by link busy?
I don't know. That's a good question. It's following the vignette. So I tried to follow it when I was preparing, but it's still a bit confusing for me. But I really do like the interactivity of this. Kritika.
Yeah, so when we are giving it our own data, what are the columns that it expects? Any idea?
It's going to, let's go back to the references. It wants things in a certain format for sure. Actually, I don't know what this is. I guess these are papers that feature Circos plots. User guide. Okay. So here, let me put this in the chat. Okay, so this is a vignette. So if you guys are familiar with that, I tried to follow this vignette, but using the Shiny app, and I didn't do so well. But this really tells you how each of the data sets, but to answer basically what using the example data set would be. But to answer your question, it should be in here. I'm not sure how we need to format it.
Two more questions to piggyback on that one. I see that at least in the example that you showed, or like the code that you just showed, it was HG19. Any idea if this is restrained to HG19 build only, or can this also work with HG38? Or is there any such concern that it will not work with any other genomic build for that matter?
I'm not sure. I think 38 would be, for the most part, compatible with HG19, but we should probably double check on that. I mean, as far as in this case, I think just the chromosome naming you would have to be careful with.
And is there any idea if there's any restriction with respect to what file size can this?
Good question.
Use?
I don't know. I can follow up on that as well.
Okay.
But yeah, a lot of potential there. And we need people to try it out in the community.